How many people does it take to run a state-scale cyber attack now? Researchers say that just one operator and a cluster of AI agents compromised at least 85 accounts in an attack on a government. The old price of entry was a funded crew with rare skills, but that price is collapsing. And here's the claim I'll stand behind. The specialist team has stopped being the gate between one person's intent and institutional-scale power. That is today's lead. Also in today's episode, open models filling every layer of the stack, one poisoned package reaching thousands of companies, and AI labs learning to trade power and finance infrastructure. Come with me, let's get into it. At least 85 Taiwanese government accounts were compromised. More than 2,500 personnel records were taken. The intruders reached a nuclear safety agency and 7 energy companies. Taiwan's Cybersecurity Authority confirmed an AI-assisted attack, but did not necessarily endorse researchers' separate account that a coordinated cluster of open-source AI agents carried out the work. Security researchers say that the campaign began around July 20th. So, who was actually running this attack? It's easy to think that maybe another government did this, and of course sensationalists will say that it was machines deciding to target the government on their own. But that isn't what Taiwan described. A human operator actually set the objective. The agents handled reconnaissance, tested credentials, moved between systems, and planned their own next steps as the campaign unfolded. Now that last part, it separates this from the automated attacks that we've already known for decades. A traditional script follows a route that somebody wrote in advance, but these agents could reach a blocked path, choose another route, coordinate, and keep going without handing every decision back to a person. The result looked like the work of a specialized team, but it was actually just one person. The team happened to run in the software. Researcher Chris Thomas made a key distinction about this new wave of attacks. Autonomy at the keyboard doesn't mean autonomy of intent. The operator still decided what to pursue. AI just multiplied that person's reach. Now, assessment did link the intrusion to a China-connected group, or a China-connected individual at least, but investigators haven't confirmed that attribution yet. They're still working through the evidence. State-scale impact alone does not settle who was behind it. Now, look at how defenders found the campaign. The Israeli cybersecurity firm Dream noticed behavior that human crews struggle to produce. The agents moved at machine speed. They branched across several routes, pivoted quickly, and never lost the thread between their actions. So think of it like footprints across fresh snow. A human team leaves one pattern, but coordinated agents leave a different kind. So once defenders know that second pattern, they can search for it anywhere. Dream flagged the anomaly, and Taiwanese defenders unwound the intrusion. They contained it within weeks. Once researchers published the detection method, other governments and energy operators could use it to look for the same behavioral signature. Now that is the other half of this capability shift. One operator did gain the reach of a whole cyber attack crew, but defenders gained a portable way to recognize that crew while it's moving. A person sets the direction, an agent finds the routes that nobody spelled out, and the surrounding system has to recognize the behavior instead of waiting for some known script. Now, the old advantage belongs to whoever could fund the biggest specialist team. Now, that barrier has begun to fall for attackers, but it's also falling for defenders. And the side that will pull ahead is whichever one more quickly and efficiently shares what it learns. All right, that portable defense depends on access, and now people outside the largest labs can download models at a scale that recently required paid subscriptions. So did open access expand only at the giant model tier, or did the rest of the stack also arrive with it? A model file alone doesn't really settle that. Someone still has to make it run. Large models need efficient software and serious hardware. Smaller models need enough speed to become useful on devices that people already own. Open weights means the model file itself can be downloaded and run on hardware you control, assuming you have sufficient compute. That does give researchers, businesses, and governments an alternative to sending every request through a company's metered service. On August 12th, Alibaba released Qwen 3.8 Max at a scale of 2.4 trillion parameters. Now, parameters are the learned settings inside a model. The figure describes sheer size. It's not a verified score against proprietary systems, because function is just as important. The widely used OpenRunner VLLM was ready when the weights arrived, and that matters because a downloadable file is useless without software to actually run it efficiently. It's like an engine sitting on a pallet. Qwen uses a mixture of experts' design. So picture a huge workshop. setup where only the stations needed for each job is switched on at a time. The whole system then can hold enormous capacity without activating every part for every word. Its attention system also shifts between a quick scan and a more intensive look, so memory use doesn't climb as fast when it handles really long material. Alibaba had opened the model through its hosted Qwen work service on August 3rd and promised downloadable weights within a week, and they arrived on August 12th. And that same day, DeepSeek V4 Pro left preview and became generally available under an MIT license. It has 1.6 trillion parameters, where only a small share works on each token. It can handle up to 1 million tokens of context, and its API price for cached input, for now, is under a cent per million tokens. Now, those prices won't necessarily last. DeepSeek has signaled that they will rise. Its benchmark figures also come from DeepSeek alone. They have not yet been independently replicated. So availability is established here. The model standing against competitors still does need outside testing, and the lasting cost will depend on what it takes to run at scale. Below those giant systems, NVIDIA released a 30 billion parameter model built for specialized agent work on one workstation GPU, and the company says that it generates tokens about 4 times faster than its previous generation, which was already pretty fast. NVIDIA also released an open routing layer that sends each request to the cheapest model capable of handling it, and NVIDIA reports cost cuts ranging from roughly 1/4 to 3/4. You stop paying the largest model to do the work that a smaller one can handle. And this isn't the first router we've seen, but it is the most recent version. And then Liquid AI pushed the whole stack onto a phone. Its vision language model can inspect images and reason about them while staying just on the handset. It takes about 3 gigabytes and generates roughly 20 tokens a second. No request ever has to leave the device. So the answer is the whole stack. A frontier scale model, a generally available workhorse model, cost routing software, and on-phone vision all arrived within the same news cycle. Proprietary paywalls rely on capability staying scarce long enough for access fees to compound into lasting advantage. Open releases keep shortening that window, and as access spreads, the next pressure point becomes the trusted software that thousands of teams install between themselves and those models. All right, that expanding stack still runs through shared choke points, and one poisoned developer package exposed credentials from more than 2,500 organizations. And that affected list includes Microsoft, Amazon, Cisco, Samsung, and Salesforce. So how did attackers get inside so many well-resourced companies in just 40 minutes? Sometime in March, attackers slipped tampered versions of LiteLLM into the Python package index. That's the official public repository where developers download Python software. LiteLLM helps developers connect software to different AI providers. Thousands of teams use it because one shared layer is easier than building and maintaining every connection themselves. That convenience, though, also created an unusually rich target. During a 40-minute window, organizations downloaded what they didn't know were poisoned builds from a place that they trusted. The theft then arrived inside the software that the victims had chosen to install. That is a supply chain attack. Instead of breaking separately into thousands of different buildings, for example, an attacker poisons the delivery truck that all of them already just waved through the gate. The malicious versions stole the access keys to cloud systems, code repositories, software publishing, internal environments, and AI providers. Hudson Rock reconstructed the scope from a single archive, measuring 153 gigabytes. CloudSec and Hudson Rock disclosed the breach. Independent researcher Kevin Beaumont checked the data against multiple victims. The campaign traces back to earlier compromises of a popular vulnerability scanner and other software packages. A group calling itself Team PCP took the credit. Researchers describe it as a loose but very capable crew made up largely of teenagers, and they've largely corroborated the group's account. And that detail should actually give you pause. Some of the best funded technology and security teams on Earth had their credentials lifted by adolescents who found the trusted point that everyone shared. And Beaumont put it really well here. He called it a massive supply chain breach due to poor AI security, not because AI is the threat, but teens can run circles around orgs obsessed with rushing out AI and poor DevOps security. So the models didn't carry out this theft. The surrounding trust system failed. Today, possession of a secret string often equals authorization. If you hold the token or the key or the password, the system assumes that you're the person or the service that received it. You steal that string, then you inherit its power. Now, that design made sense when checking identity continuously was expensive, and it's never really been perfect, but it's been what we've had so far. AI systems, though, now put far more pressure on that trust model because they can act faster, connect more services, and multiply the value of every stolen credential. There is an encouraging response inside this breach, however. The campaign stayed hidden for months. Once researchers surfaced the file, an open network checked it against multiple organizations and corroborated the scope within days. So here's what's coming next. Credentials that expire quickly, work only for one narrow task, and lose their authority the moment they're used outside the setting that created them. Then stealing a key becomes much less useful. A poisoned package can reach thousands of organizations at once, but shared verification can reach them too. All right, that software problem concentrated digital risk. Now families and businesses near data centers face a different concentrated cost, the power bill for infrastructure built next to them. AI labs now sign 20-year energy deals, recruit commodity specialists, and bring asset managers into data center ventures. Why does a model company suddenly need to operate like a utility and a finance firm? Anthropic has committed $9.1 billion over 20 years for 191 megawatts at a campus in Rockdale, Texas. Riot platforms had filled the site with Bitcoin miners. The existing power connections and cooling will now serve AI compute. Now, there's something really fitting in that conversion. Companies are now redirecting infrastructure that once mined cryptocurrency toward AI instead, a capability that keeps spreading. The size of the commitment also shows how much financial weight now sits beneath every model response. Labs need power for decades. They need protection from changing electricity and gas prices. They need outside investors willing to carry part of the construction risk. Anthropic formed a data center venture with Macquarie Asset Management and Singapore's GIC. The asset managers will supply the equity. The contract contains an unusual term, too. Anthropic agreed to absorb any increase in consumer electricity prices caused by the facilities. Now, no one has yet tested that promise under real pressure. We don't know how it will work if costs happen to jump sharply, or a dispute arises over what caused the increase in the first place, or the project's economics simply change. It remains a contract term rather than, of course, a delivered outcome. Still, the direction does matter here. Operators have often pushed this cost onto nearby ratepayers, and now they're deciding who pays it before construction even starts. That means the town doesn't have to discover the full bargain later in their utility bill. And this concession didn't appear from nowhere either. More than 500 local bans and moratoriums mean that these companies can no longer treat approval as simply a formality. Texas also launched a grid audit backed by operators that brought the cost of enormous speculative power requests into public view. Community pressure changed the price of proceeding. Absorbing local electricity increases can now cost less than losing the project entirely. Now, OpenAI is making a parallel move. It's hiring a power trading lead with a decade of experience in U.S. electricity and natural gas markets. A frontier lab now needs someone who can hedge its exposure when energy prices start to move. The financial risk is spreading outward, too. NVIDIA and 6 large asset managers are targeting more than $500 billion in compute-backed financing. Broadcom is building Anthropic's chips with Blackstone Capital. Google is tapping bondholders to fund other infrastructure providers. When the richest technology companies stop carrying these bets entirely on their own books, then the scale has to outrun what one treasury wants to hold. Asset managers, bondholders, and sovereign funds now share the exposure. Now, there is still an escape route from public grid accounting. Amazon's permitted Pecos County campus would run off-grid on its own gas turbines. Because it generates power on site, it skips the regulatory process that helped force Anthropic's price protection clause into public view. However, it also pollutes like crazy. Now, we do need the compute build-out. We also need its costs to land where contracts and communities and investors can see them and respond to them. Rockdale shows that these costs are beginning to move onto the balance sheet of the company creating the demand. But how durable that shift really is will depend on whether Anthropic keeps its promise and other companies keep their promise, even under pressure. All right, closing out for today. Having a team used to mean a room full of specialists, a management chart, and the money to keep everyone working together. But now, just recently, one person directed AI agents through a state-scale intrusion. open models arrived from giant clusters down to phones. A mostly teenage crew reached thousands of major organizations through one trusted package. AI labs added power traders, asset managers, and decades-long energy contracts to the work of building models. The org chart has stopped being the gate, and that expands what one person, one community, or one small organization can attempt. It also magnifies the consequences of the choices surrounding that capability. Taiwan shows both sides clearly. One operator gained the reach of a cyber unit. Defenders, though, recognized the agents by their behavior, contained the attack, and published the signature for everyone else to use. The LiteLLM breach exposed the weakness of trust built around hoarded secrets, and it also showed an open research network checking the evidence across victims within days. Open Weights keeps giving more people the capacity to build, to attack, yes, and also to defend. Community pressure is also starting to put infrastructure costs into contracts before they quietly reach household bills. This is where the optimism lives. Institutional scale capability is becoming something far more people can assemble. Detection methods, model weights, research findings, and cost accounting can spread just as widely. The specialist team's monopoly is ending. The next advantage then belongs to people who can coordinate intelligence, share what they learn, and build systems where everyone gets to check the work. That is how either the attackers or the defenders win out here. Whichever side is able to most efficiently and effectively share what they learn will come out on top. See you tomorrow.